Hello students, it's Nazia Begum here, your physics lecturer, welcoming you all in today's lecture. So the topic for today is angle of contact. Okay, so what is angle of contact? Here in front of you, you can see two figures are there. Okay, two containers are there in which a liquid is filled. Now, inside the container you can see in diagram A, in figure A, you can see that in the container water is filled, and in figure B, you can see that mercury is filled inside. Okay, you can also notice that the shape of surface is different in both the cases. For figure A, where water is filled, the shape of surface is concave, but for figure B, where mercury is filled in container, the shape of the surface is convex. Okay, different types of shapes are there. So, according to these shapes, we are having different types of angles between the shape and the wall of the container, which is inside the liquid. Okay, most of the students do one mistake. What mistake they do? They make the angle between the surface. Okay, they make the angle between the surface, this one surface, and the exterior wall, but it is wrong. When we are talking about the angle of contact, so there is this angle between this surface and the wall of container inside. Okay, inside the liquid. Okay, the side where liquid is there, that side wall is there, that wall makes angle of contact with the surface, not the outside one. Okay, that is wrong. Inside only we are having our angle of contact. Okay, so here you can see that two different surfaces are there. So in case of figure A, if we draw one tangent, one line, okay, which is coming out from A, point A, which is the point A is the point where the surface is touching the container. Okay, from that surface we will draw one tangent. You can see AT is that tangent. Okay, and that tangent and the wall of container, the angle between these two is called angle of contact. Okay, so here in case of water you can see the value of angle of contact is less than 90 degree. But in case of mercury, in figure B, you can see that when we draw one tangent from point A is that point where the surface is touching the wall of container. So from that point, if we draw one tangent for this surface in case of mercury, so that tangent you can see there as AT. Okay, so the angle between AT and the wall of the container inside the liquid, so that angle is more than 90 degree. Okay, so that is called angle of contact. So how we can define angle of contact? So here in front of you, you have the definition. Angle of contact is the angle which the tangent drawn to the liquid surface makes with the solid surface inside the liquid. That solid surface means walls of the container only. Okay, so angle of contact is between the tangent which we draw for the surface. Is it clear? It is between the tangent and the solid surface inside the liquid, not the outside one. Okay, so two general mistake which student commit. First, either they make angle between the surface and the solid surface inside the liquid, or with the surface and solid surface outside the liquid. Both the things are wrong. This is the angle of contact between the tangent drawn from the surface and the solid surface inside the liquid. So I hope angle of contact is clear to you now. Okay, and why we call it angle of contact? Because the point from where the surface is contacting the wall of the container, at that point only we have drawn the tangent. So from that point, because we are making that angle, that's why it is called angle of contact. Okay. Then here you have seen that when the angle of contact for a particular liquid is less than 90 degree, so the shape of the surface will be concave. If the angle of contact is more than 90 degree, then the shape of the liquid will be convex. If the angle of contact is 90 degree, that means what will be there? The shape of the surface will be flat only, plain surface will be there. Okay, but it is a very rare case. Then one more thing we have to understand about the cohesive and adhesive forces. So first of all, let me tell you what is cohesive force and what is adhesive force. You all have to listen it very carefully. Okay, cohesive force. The force of attraction between the molecules present in same material is called cohesive force. Suppose we are having one material, okay? So inside that material, whatever molecules are there, the force between those molecules is called cohesive force. Okay? Now let's come to adhesive force. Have you heard this word adhesive somewhere? Yes, you have heard it uh, in case of the agents which are used to stick two things. Okay, in Fevicol, in that Fevistick, etc. You have heard this word adhesive, because adhesive means the force of attraction between the molecules of two different materials. Are you understanding this? Cohesive force is the force of attraction between the molecule of the same material. Then force of adhesion or adhesive force is the force of attraction between the molecules of two different substances. Okay, if we talk about the water, okay, so in case of water, the molecules are attracting each other with some cohesive force. But when we pour the water inside a container, so that time water and the glass, suppose one glass container we are taking, so water and glass, their molecules start attracting each other. That will be the adhesive force. Is it clear to you? If we talk about the molecules inside the water only, that is cohesive force, and when water is poured inside the glass container, so that time that molecules of glass and molecules of water, they also apply force on each other, they also attract each other, so that will be the adhesive force. Okay, so in case of water and glass, adhesive force is more than the cohesive force, and that's why the water stick on the glass. Okay, if adhesive force is more than cohesive force, then the substances stick to each other. Okay, so if suppose we once pour the liquid inside a glass container, then when we make the container empty, that time also we can see that some drops of water stick on the walls of container. That is because of the adhesive force only. Okay, and when the angle of contact is less than 90 degree, so that time we have to understand that adhesive force is more than cohesive force. Okay, now in case of mercury, see, mercury is a very dense liquid. Okay, the force of attraction among the molecules of mercury is very high, so the cohesive force for mercury is very high. Okay, so when mercury is filled in a glass container, so the adhesive force between mercury and glass is very less in comparison with the cohesive force between the molecules of mercury. Are you understanding this? Mercury is very dense liquid. The molecules are very close to each other. They are having very strong attraction with each other. So cohesive force is very high there. Okay, so when mercury is filled inside a glass container, okay, so when we make the container empty, that time we see that not a single drop, not a single point of mercury is left in the glass. Why this happen? because the adhesive force between glass and mercury is very less in comparison with the cohesive force of mercury. That's why mercury does not stick on glass. Okay. So I hope now you all have understood angle of contact and its relation for surface shape and the relation with adhesive and cohesive force. So when the adhesive force is less than cohesive force, then surface is having a shape of convex type and the angle of contact is also more than 90 degree. Okay. So here we can see let us understand how the two liquids filled in glass tubes have different values of angle of contact. Okay, so these different values are there because of force of adhesion and cohesion only, which I have explained you. If the force of cohesion is less than force of adhesion, that time the surface will have concave shape. When the force of cohesion is more than the force of adhesion, that time surface is having the convex shape. Okay. Now the next topic for today is capillary action. So what does the meaning of this word capillary? See, capillary word is derived from Latin word capilla. Capilla means hair. Okay. So when we talk about capillary action, so in this we are having a tube whose length is very large in comparison with the radius, so that radius can be neglected, like in case of our hair. Okay, the radius of our hair is very less in comparison with the length of hair, that it can be neglected. Okay, so in the similar manner, if we take a tube whose length is very large in comparison with its radius, so that type of tube is called capillary tube. Okay, so if we put that type of tube inside a liquid, so liquid either go up or go down inside that tube. Okay, so when such a tube is dipped in a liquid, if suppose that liquid is water, that means the force of cohesion is less in comparison with addition. So that time what happen? The liquid level in the tube rises above its level in the container. So here you can see in the diagram, this is the level of water in container. But when we put capillary tube inside it, the water level inside the tube has raised up. Okay, but in case of a liquid whose cohesive force is more than the adhesive force, okay, so that time what happen? The level of that liquid goes down inside the capillary tube. Okay, so here in container this is the level of the mercury, but when the capillary tube is dipped inside it, the level decreases and reaches here. Okay, so two types of actions are there in capillary tube. Two actions are there: either the liquid goes down in the capillary tube or it will go up, and the direction of motion of liquid, whether it is going up or down, that totally depends upon the nature of the liquid. Okay, whether the liquid is very thin or very dense. Okay, according to that only the liquid will having the cohesive force, and according to that only the level will go up or down. Okay, and this phenomena is called capillarity. So here you can see the phenomena of rise or fall of a liquid in a capillary tube is called capillarity or capillary action. Now let's discuss some examples of capillarity. First, blotting paper used to absorb extra ink from a page has fine pores which act like capillary tube. Okay, so suppose somewhere any liquid is fallen down and we have to clean it up. So what type of clothes we use? The clothes in which so much pore is there. Blotting paper is there. Blotting paper is having so many pores inside it. That small pores work like capillary tube. okay, and when they come in contact with the liquid go up in the paper and the paper absorb all the liquid, okay. The same case is there in case of sponge. Whenever any liquid is there and if we put sponge on that liquid, that sponge absorb all the liquid. So actually that sponge does not absorb the liquid, but because in sponge so many pores are there, fine pores are there, so those pores work like capillary tube. So when liquid comes in contact with those pores, the liquid goes up, okay, and goes inside the sponge, okay. Then we are having lamps in our home, okay. In Diwali you all have used lamps with that bati which is called wick, cotton wick, okay. So when uh, that cotton wick is pour in oil, okay, inside the lamp we are having oil, then we are having a wick, okay. One end of the wick is inside the oil, other end is free, which we burn with the matchstick, okay. And when we burn it once, it continuously keep burning by absorbing the oil from the lamp. So this is also one example of capillarity, that cotton wick is having pore inside it, okay. Cotton is a fluffy material, so when we make wick of that, so that time inside that cotton wick so many small pores are created, and that pores acts like capillary tube, and the oil rises up in that capillary tube and reaches to other end, and that's why that lamp continue burning, okay. Water rises in innumerable capillarities in the stem of the plants and trees and reaches the leaves, okay. So when roots and stems, see, root absorb the water from the soil, that is also one action of capillarity. In roots also so many pores are there. After root, stem is there, the water goes up in the stem and in different parts of the plants, okay. That is also action of capillarity. In stems also so many small pores are there, and through that pores capillary action takes place. Farmers plough their fields for preserving moisture in the soil. By ploughing, the capillaries formed in the upper layer of the soil are broken. Hence, water trapped in the soil is taken up by the plants. Then, towels made of coarse cloth are used for drying the body after taking bath due to capillary action. So I hope now you all have understood what is capillarity, and in our day-to-day life, in so many places in our day-to-day life, we are having the capillary action. So students, this is it for today's lecture. In next lecture, we will discuss some more interesting phenomena related to liquids. Okay. So see you in next lecture. Till then, goodbye. Take care. Do some productive work. And the most important thing, be healthy, be safe.